Thanks for the introduction. As he said, I'm Jerod Johnson. I'm a technology evangelist for CData Software. That's my Twitter handle. It's okay. And then CData's Twitter handle has more information if you're looking for more information about that. So this afternoon, I want to talk to you about SQL for web APIs, so simplifying data access for API consumers. So what we're going to look at is some popular APIs that have SQL functionality or SQL endpoints, so APIs that provide SQL access. We'll talk a little bit about why an API would want SQL access, or why you as an API builder may want to provide SQL access. You as an API consumer might be interested in API or SQL access for your APIs. I'll talk about some integration challenges that come with SQL access for APIs. I'll talk about standard drivers, which are a way to provide SQL access to your APIs, and then we'll close out briefly covering a case study of a company called bouquet.ai that really leveraged this SQL access for web APIs. So we'll start with some popular APIs that provide SQL functionality. So Google BigQuery is a big data, cloud-based big data store. Couchbase, for anyone that's not familiar, is a NoSQL data store. Salesforce, widely popular CRM application. And I'll go into some detail on those platforms and how they provide SQL access, what that looks like. And then there are a myriad other APIs that provide SQL access. So Amazon S3 has SQL access through the Athena platform. You can do SQL access to Elasticsearch, MongoDB, SAP Business One, Snowflake, Viva Vault, and then there are many others. So let's get started with Google BigQuery because it actually uses standard SQL, so the other platforms use kind of their own take on SQL. So we'll start here, we'll start simple, we'll get more complex as we go. So standard SQL, Google BigQuery allows you to access your Google BigQuery data through their API using standard SQL based on the 2011 standard. So your standard with clauses, SQL functions, so if you need to do some aggregation, if you're looking to extract values from fields, you can do that as well. You can perform subqueries, so whether that's a subselect or a select within a where clause, you can do that. If you're working with arrays or structures within your Google BigQuery data, the 2011 SQL standard enables that. And it's not just for querying data, but it's also for inserting, updating, and deleting. So you're getting the full gamut of the Google BigQuery API access, so reading and writing, but through SQL queries. And then lastly, you can perform these complex SQL queries that anyone that's used to working with relational data is familiar with, but you can do it with this cloud-based, API-based data store. So this is a simple Python script. So the Python SDK for Google BigQuery is talking to the BigQuery API through the SQL-enabled endpoint. And as you can see, there's nothing tricky to be done. I don't have to identify the object within the script. So on the API backend, it's not going to a specific data set endpoint. It's just going to the Google BigQuery endpoint that supports SQL. And it will push that SQL query to Google BigQuery, and then it returns the response in an array that you can iterate over to perform whatever operations you need. If you need to report on it, if you need to pass that to another API or another microservice, you can do that as well. So the next example is Salesforce. So they have two SQL-like languages that they provide access to. So SQL is one. It's the Salesforce object query language, and it's very SQL-like. I think that there are some syntax issues that aren't exactly the same, so they can't call it pure SQL. But it provides SQL-like access to Salesforce objects, so hence the name. And the format looks exactly like SQL. So a select statement, you're going to select some fields from your object where some criteria are being met. And those criteria could be filters, they could be ordering, it could be grouping if you're performing aggregations. So a simple JavaScript example. Again, there's nothing complicated here with the JavaScript framework for Salesforce, but you don't have to know necessarily the full SDK, you just need to know how to pass the SQL query. And if you were doing a pure API access to Salesforce, you wouldn't need to know how to specifically talk to the user endpoint. You would just need to know how to talk to the SQL endpoint. So you can construct your SQL queries or your SQL queries, pass those directly to that SQL endpoint, and get your response back, iterate over it as needed. And then we have the Salesforce Object Search language. So this is probably the least SQL-like access that you can get. It's still a query, but it's not very SQL-like. Instead, you're doing text-based searching of your Salesforce objects. But again, you just need to know how to construct that query. You're not beholden to necessarily a text-based search API endpoint or passing, searching, filtering, or searching parameters to a specific Salesforce object endpoint. You simply need to know how to construct that SOSL query to be able to find the names of accounts, or find all of the accounts whose names match a specific value. So again, we've got an example of using it. The result is returned by the API that you can iterate over as needed. So the last example that we'll really dig into is Couchbase. So as I mentioned, Couchbase is a NoSQL data store. All of the data that's stored in a Couchbase database is actually a collection of JSON documents. So you get the full capabilities that are available from storing data as JSON. So you can nest data, you can have arrays within the JSON documents. Their primary kind of sample data set is they call it the brewery data set, but each object can be different. So you could have one object that represents a brewery, you could have another object that represents a beer. It's a very flexible data set. But with that flexibility comes some challenges when it comes to integrating with the data. So they have two languages based on the two services that they provide on top of their data that allow for SQL-like access. So the first is Nickel, and it gets its name from the first normal form. And then there's SQL++, which was a variation of SQL that was developed that provides SQL++ access, so in the same vein as C and C++. It's SQL and a little bit more. Both of these SQL-like languages provide SQL-like syntax for querying your JSON documents. So you're going to see a similar query to what you would see if you were talking to a relational database. So a select from one or more fields from some document where you have some filtering criteria. The one thing that changes is that the dot notation in Nickel and SQL++ allows you to drill down into a JSON document. So if we look at the Nickel query example, I'm saying select name contact dot email from default. What that means is that default collection has some JSON documents that have a contact object with an email field within that object. So it gives me a way to easily drill down into my JSON documents to get the information that I need, and only the information that I need. So as that response is returned, I'm not going to be given the full JSON document. I will only be given the name field and the email field. So it's less data to go over the wire. It's less data for you to have to process as you integrate with this API. And in the analytics query example, so this is with SQL++, we see the same kind of thing. So the airports collection has some documents that have an address sub-object with a country field in it. And again, you're seeing that pure integration where you get only the information that you need. And you're able to do that without necessarily needing to know how to drill down into the API, how to work with all of the functionality of the API. If you're able to construct these SQL-like queries based on an understanding of your documents, then you simply pass that query either through the SDK or directly to the Nickel or SQL++ endpoint to get your data returned. So why provide SQL at all, right? So this is, I always feel a little weird talking about this because we're here at the API Platform Summit and I'm talking about SQL. It doesn't always seem to fit. So SQL in and of itself, to start with, is kind of a self-describing API. So all of your objects and your fields and your functions are defined by the SQL syntax, within the SQL syntax, and they're fully discoverable. So if you can create a query that pulls what would look like database metadata from a database, then you can pull all of the metadata from an API. So you can get information about what endpoints exist, what objects are available, what fields are available within those objects, the data types for those fields within those objects. You can even pull information about relationships between objects from an API. And you can do all of this using SQL only. This kind of access is going to ease integration and application development. So instead of having to learn everything about an API, all you need to know is how to interact with the SQL endpoint for the API. And so that can work both ways. So if you're developing an application to work with data, you only need to be able to understand how to query a database for data. And if you're on the other end where you're generating an API, you can provide the SQL access in the same way. So as you design your backend data, you can know that as you build your SQL API, your SQL access, that anyone that's consuming your API is going to be able to discover information about your API in that way. Another big benefit is that you get simplified interfacing with popular tooling. So in popular tooling, I'm talking about your business intelligence tools and platforms, ETL, reporting, even machine learning, artificial intelligence, any of these tools that are already capable of talking to databases or are designed to talk to databases. So for instance, Tableau, every time you modify the visualization in Tableau, Tableau is generating a SQL query on the back end to get information to populate that visualization. So as a developer or somebody designing an API, you only need a way to consume that SQL query and pass it along to your API. So it eases that integration. You're not required to build some custom connector for your API like you would have to if you didn't have that SQL access already. And the last thing that I'll mention in brief is you get to leverage server-side processing. So you know, because you're passing a very specific query to Salesforce or to Google BigQuery or to Couchbase, you know that you're relying on Salesforce to do the data processing. You're relying on Google BigQuery to do the data processing, so that the response that you get back is the minimal amount of information that you need to get exactly what you want as you build your applications. So examples of when SQL makes sense. If you're retrieving data from multiple related objects, if you're retrieving parts of specific fields. So with SQL, you can extract, say, the year out of a date time. You can perform an operation on a numeric value. And that functionality may not exist natively within an API, or it may not be something that's easily designable as you create your API. But with SQL functionality, that's already there. It's already in the syntax. It already exists. If you need to do something like counting the number of specific records that meet a specified criteria, it's simple enough to pass a filter to an API endpoint. It's not necessarily simple to ask that API to count the number of results and only give you that number back, but SQL allows you to do that. And then the last one is if you needed to sort. So not every API is going to support sorting, or it's not going to support sorting on the fields that you need it to support. So if you have this SQL access or you're working with an API that provides this SQL functionality, you're going to be able to, again, get exactly the results that you need. So what are some of the integration challenges that come with working with these APIs that have SQL endpoints? So SQL access does not always mean a SQL response. So if you're a developer or you're writing an application that is used to working with databases, the response that you get back from your API, even though you're using SQL or something that's SQL-like, may not be a database. So there's going to be some integration challenges there. There's a little work to be done in that vein. So as I mentioned, Couchbase returns JSON documents, not a database table. So you would need to be able to process that response appropriately. SQL access is not uniform across APIs. So if you looked at the examples that I presented, the SDKs for Python and Node.js and JavaScript obviously are different, but even if you look at the same SDK, so if I were to look at the Python SDK for all three of those platforms, working with SQL within those platforms is not always the same. So as you develop, you're still looking at that problem where your data is spread out, it's siloed behind different APIs, so you need to know the different ways that you interact with data. Not all APIs are going to provide that SQL access, which is another challenge. And I don't know, when I presented in Austin, I was the third of 3 presenters to use this image. I don't know how many times you've seen it, but there it is again. If you have seen it, here it is anew if you haven't seen it. Programmable web, it catalogs public APIs. So we're over 22,000 public APIs now, 2,000 per year, and Imagine that number is going to continue to grow, and that doesn't even include private APIs. So if you're building internal apps to consume private APIs, that's another step that you have to take. So the real question here is, can your API integration keep up? Can your API generation keep up? So as you create APIs or as you integrate with other APIs, are you able to keep up? So we're moving away from databases and into SaaS applications, which means that there are more and more APIs that you need to be able to work with, that you need to be able to consume. So this is where technologies that are called standard drivers come into play. So anyone that's familiar with working with a database is going to be familiar with the ubiquitous technologies, JDBC, ODBC, ADO.NET. These are all standard software connectors that allow SQL access to typically databases. Vendors now are beginning to see that applications still want to use SQL. Data scientists still want to use SQL. These data platforms, these visualization tools, reporting tools are still using SQL. So vendors are creating their own standard drivers for things that are not databases. So you get SQL access to your APIs, or you have these SQL endpoints within your APIs that enable that SQL functionality. So Salesforce has an ODBC driver. Oracle NetSuite has an ODBC driver. Couchbase, they have JDBC, ODBC drivers. Google BigQuery has the same. And then many of the larger big data NoSQL data stores are providing the same kind of driver for their API. So what does that look like? What does it look like to provide SQL access to an API? How do you model an API as a database? Your tables and views are going to correspond to your resource collections. So things like orders, accounts, pages, users, all of these API, what would typically be API endpoints, get surfaced as tables and views within whatever framework, whatever language you're using, whatever application you're using. So, and tables and views, for anyone that's not familiar, if an API endpoint provides read and write access, that will surface itself as a table. If an API endpoint is read-only, it surfaces itself as a view. Individual elements within those resource collections will be a row in the table. So every account gets a new row. If you're looking at Facebook as a database, every post would be a row within a database table. The sub-collection relationships that you're used to working with as you go through your APIs, as you integrate, are going to be maintained. So the relationship that exists between orders and order line items. Your CRUD operations are translated to SQL statements. So all of your HTTP get, put, post, and delete are going to become select, insert, update, delete. And then those operations and functions that don't have a direct SQL correlation are going to be surfaced as stored procedures. So something like uploading a document, or generating a new report, or sending an email. This SQL access is ultimately going to simplify developer integration. And that is important for anyone that's a developer, and providing SQL access to your API if you are generating APIs is going to be important to anyone that's consuming your API. So instead of having to learn to talk to dozens or, potentially hundreds of different APIs to learn dozens of new SDKs, you simply need to know how to talk to a database. So the only telltale information here that tells me that I'm talking to Salesforce is the fact that the word Salesforce is there in the connection string, and then the properties that I would use to connect. So you're able to work with your data behind any API that you want the same. So it always looks like a database. So these are some examples of SQL compliant queries. So you can perform complex joins, aggregations, you can even update data, as I mentioned before. So let's take a little bit to talk about a case study. So Bouquet.ai has a natural language AI platform called Eris. And the design behind this platform is to be able to take natural language queries, so questions, what was the win rate for opportunities by industry for the past year or for the past quarter? And it translates that natural language query into a SQL query, which is great if your data is in a database, but it's not as useful if the data that you want to ask questions about is locked behind an API. So with standard drivers, when Bouquet.ai embedded standard drivers for APIs, they were now able to ask natural language questions about any API that they had a standard driver for. So they could ask a question about their Salesforce data or their Facebook data. They could ask questions about these big data and NoSQL platforms. So the takeaway here is that you can get SQL benefits for all APIs, whether that's through a SQL endpoint within your API or through a company providing a standard driver like Salesforce does, or you creating a standard driver for your own API. SQL continues to be the lingua franca of data access. So people are developing tools that talk to databases, and so providing SQL access to APIs helps in that way. API growth continues unabated, so more data to consume. If there's only one way to get to it, it makes life a lot easier. So rapid application development, ease of use for citizen analysts, and insulation from API changes. Those are your benefits. So if you have questions, let me know. Thanks.